Okay, this is for integrated 2, 5.1.2. The notes that we're going to be covering here have to do with multiple representations of quadratic functions. So here we've got this situation with a water balloon toss. So we've got Maggie, Imp, Jin, and Al with 4 different participants here. And then we're going to go through and take a look at each one of their water balloon tosses and just kind of compare some information. Okay, so first and foremost, we have got Maggie. And we know some information. So she has placed her slingshot at the 3-yard line. And then we know that her balloon or water balloon travels the path of this parabola. And we've got this equation to go with it. So let me go ahead and set up a table. I know that by being placed at the 3-yard line, that means that she's starting at 3, 0. Then I'm just going to start plugging numbers in. So if I plug in 4, I'm going to get 10, 5, 18, and I'm going to keep doing this until I start seeing that duplication in my y values. At this point, if you take a look at the y, the balloon is still traveling upwards because my y values are increasing. Okay, still increasing, still increasing. Oh, it's going pretty high, still increasing. Okay, here we go. So it looks like we're starting to come back down again. So since I've got the duplication, I know that my vertex is going to be dead center between 8 and 9. If I plug 8.5 in, looks like I'm going to get a vertex of 8.5, 30.25. I'm going to use symmetry to find the rest of the points. So if I wanted to find point 10, then I know that its height would match with 7, which is going to be 28. And then if I wanted to find 11, then I know that it would match with 6. So again, using the idea of symmetry. So here's our graph of Maggie's information. So we can see that it takes off at 3, and it looks like it's going to land at 14. So traveled a pretty good long horizontal distance, and vertically it went up to a height of 30.25. Okay, let's take a look at Imp now. So the information for this one is given in a table. So we have to be able to extract the information from the table. So the first thing that I am going to do is start looking for that duplication in the y values. And I see it. I see at 6, I've got 24. At 8, I've got 24. I even have dead center between those two at 725. So it looks like I've got my vertex. So this one is going to go up to a maximum height of 25. So previously, that one went up to 30. So we know this one isn't going to be as high. I'm going to use symmetry to find the rest of the points to get us back down to the x-axis, just like I did on the previous one. So I'm just using my symmetry. Okay, now I'm back down to the x-axis. All right, so now we can see we've got this black graph, and this is our new graph being added to it, represents the information. Notice that they took off at the 2-yard line and went out to 12, so traveled the distance of, or horizontal distance of 10. So not quite as long as the previous one, since that one was from 3 to 14, and it didn't go as high either. Okay, so let's move on to Jen. So we know with this information, we have the graph. I think the only thing we need to be able to do is just extract some points from it. So you want to choose lattice points. So what that means is you want to find points that are crossing really nice at the corner of the grid. Ideally, I want to find the vertex, and I think I see it. So it's right there up at that highest point. Then I'm going to start looking for those lattice points as well. So I've got those 2 pair of points. Notice the symmetry that's also occurring here. And I'm only choosing points that cross at the grid nicely. Okay, so now I've got this information. So I'm going to take those just to be able to translate it over to the other graph that's provided. So I'm trying to get all of them together. Okay, so here we go. So it takes off at 0, so at the beginning or at the starting line, if you want to think about it that way, and then traveled a horizontal distance of 8. So this one really didn't go very far, but it went pretty high, which is actually kind of nice. So we have this comparison that's actually happening between these 3 graphs. Let's move on to our last contestant. All right, so the information that's given to us, we have to extract it and be able to figure out what the table is going to be. So he releases the balloon from the 10-yard line, and it lands at the 16-yard line. Okay, so I'm going to go ahead and set up my table. If it's coming in at the 10-yard line, that means that it's going to be at 10, 0. If it's going to land at the 16-yard line, that's at 16, 0. Now I'm going to have to go through and try to find the middle, because we know that the maximum height is really representing our vertex at this point. So we know that the vertex is dead center in the graph. Well, if you take a look at these x-intercepts, I know that they are the same height in the graph because they have the same y value. So I'm just going to go dead center between those x's, which is going to give me 13. And then I know that the height is going to be 27 at that point. Okay, so it's not a whole heck of a lot of points, but at least it's something. So we should be able to put Al's graph on there. Okay, so now Al, we've got orange. So Al released at 10, and then it fell back down at 16. So it didn't really travel a huge amount of horizontal distance. It did go higher than the black graph, vertical distance. So if we want to now, we should be able to take a look at this and answer some questions. Now, the longest distance, that's our horizontal distance, is going to be Maggie. That was the green graph. Took off at 3 and then landed at 14. Then we also have the highest launch, which is Jen. She's going to be the one that went up the highest. So the greatest vertical distance, which is the blue graph, and that's going to be from 0 to 32.